This is an AS Maths question on vectors. Given that the point A has position vector 4i minus 5j and the point B has position vector negative 5i minus 2j, part A, what we want to do is to find the vector that takes us from A to B. So there's a couple of ways that we can do this. We can either think about what is the jump, the vector jump that takes us from point A to point B, which will basically give us the displacement vector from A to B, which is what this is, the displacement from A to B. Or we can take the second vector B and subtract the first vector A to get that displacement. So I prefer to do it the way where I look at the jump between each vector. So first of all, let's look at the jump that takes us from 4 to minus 5, and that's going to be negative 9. So if I take away 9, basically from 4 I get to negative 5. So I can write that the first part of my answer is going to be negative 9i. Now I'm going to look at the jump that takes me from negative 5 to negative 2. Let's do that in a different colour. So I want to get the jump from here to here, the j jump. And I'm going from negative 5 to negative 2. So I'm basically going up by 3. So we'll put plus 3. So that will then be plus 3j, like that. If I do it the other way by doing the second vector minus the first, then if I do minus 5 minus 4, I also get negative 9. And here if I do minus 2 minus 5, so that's like minus 2 plus 5, I also get 3. So it can be done either way. Part B, it's got here these two lines. So that's what we call modulus or size. So it's asking me to find the size of this displacement vector from A to B. And normally when we want to find the size of something, we do Pythagoras. And I want to give my answer as a simplified surd. So to find the length, the size, the modulus of this vector A to B, I do Pythagoras on the two numbers. So that's going to be negative 9 squared, or 9 squared, plus 3 squared. So if I work those out, I will get 81 plus 9. So that gives me root 90. Now it's asking me to give my answer as a simplified surd. So I'm thinking about what square numbers I can use to multiply to make 90. And I can do 9 times 10. I could also do this on my calculator as well, but I'll do square root 9 times 10. So that's root 9 times by root 10. Root 9 is 3, so we have 3 root 10 as the size of that vector, the distance between A and B basically.